but we're going to pick up where we left off. So where we stopped on Friday is that we talked about all the different corresponding parts of triangles. Now, why is that important? Because that will help us figure out what is marked and how we can compare that to a postulate that'll tell us if the triangles are congruent or not. So go to your packet and go to page 21. So everything we did on Friday is leading up to these congruency postulates, and there are 5 of them. So essentially what it's saying is that in the world of math, sometimes we have to figure out if triangles are congruent or not based off of what they've shown us. All right, so in other words, what they marked. Now, it's not going to be pretty where they mark everything like this. Sometimes they only mark a couple sides and a couple of angles. However, the patterns of those congruent sides and angles could be enough to show that those 2 triangles are congruent. And there are 5 different postulates that work like that. All right. So, by definition of congruence, but we need to show that 2 triangles are congruent. We got to show that there are some sides and some angles that are congruent. Not necessarily all of them. You just need a couple of them. Now, the first postulate, as we call them, is the SSS postulate. Now, think about what I just said. We have to show that sides and angles are congruent. So what do you think SSS stands for? Side, side, side. That's all it stands for. So SSS is just shorthand for side, side, side. That's all it means. And all it states is that 3 sides of one triangle are congruent. I'm just going to use the congruency symbol to shorthand it. To 3 sides of another triangle, then the triangles are congruent. Now, why is that? Well, what does it mean for 2 shapes to be congruent? I know it means the same, but the same what specifically? So congruent means that they're the same blank and blank. Same size and same. What do angles make though? Well, they make a triangle, but typically it's the same. What is a triangle?
It's shape.
Shape. Thank you. All right. So, same size, same shape. Well, the sides of a triangle control its size. The angles control its shape. So, if all 3 sides are congruent, automatically they're the same size. And because the sides are congruent, that means they will meet at the exact same angle. All right, between the 2 triangles. So if we look at this first example, if you notice, let's say that this is triangle A, B, C. This is triangle D, E, F. All right.
I don't have that page.
21?
21, never mind. Sorry.
You're good. All right, so if we look, we have 3 sets of matching tick marks that go with the corresponding sides. All right, so we can say that triangle ABC is congruent. Now, since I said A, B, C, that means I got to do the same thing. So start at D. Nope. It would be F, D, E. Because I have to go along the same tick marks. So that would be congruent to triangle F, D, E. Because remember, you got to state them in terms of their congruent sides. So I always look at the tick marks. So if I started at the bottom between the 1 and the 3, that means I have to start between the 1 and the 3 over here. All right, and then go down to the 1 and then over to the green. Which is what I did, down the 1 over to the green. And it's by side, side, side. Does everyone understand what side, side, side looks like? So typically with side, 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 no angles are marked at all. All 3 sides are marked though. Okay? Now, those are where the 2 triangles are separated. But what about these? So again, let's call it A, B, C, and then let's put a D here. So if I look at these 2 triangles, only 2 sides are marked between the 2 triangles, this one and this one. However, what side could I say is congruent to the other side of a triangle? It just logically it makes sense. It's congruent.
CB.
CB, why?
Because they're connected.
Well, they're connected. They share the side. So logically, could we not say that CB is congruent to itself because they share that side? Yeah. So we can mark this one as congruent to itself. So we can say BC is congruent to itself because that's the shared side. Now, this actually has a name. So if 2 triangles share a side or even share an angle, this is what they call the reflexive property. It's just a fancy name to say they share that side, so it has to be congruent. All right. So now we got 2 congruent triangles by side, 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 because all 3 sides are now marked. So I'm going to say triangle ABC is congruent. Can someone tell me how I would write the second triangle if I'm going off based off the corresponding parts? Someone has not talked yet. What do you think?
BBC.
Good, DBC. So we did ABC. So we went from in between the green and the yellow, down the yellow, and then down the blue. So we start with D, go down the yellow, and down the blue. So it'll be congruent to triangle DBC. Oops. And again, by side, side, side. So even though that third side wasn't marked, we can still mark it as congruent because they shared that side. And again, that's by the reflexive property that we can do that. All right. Any questions on side, side, side? That one's probably the easiest one to recognize because all 3 sides are marked. Now, the next couple ones, they're not necessarily hard to recognize. You just have to be careful with where things are positioned. All right. So the next postulate is SAS. So based off of what I said has to be congruent, what do you think SAS stands for? Side angle side. So in other words, we're going to have 2 sides marked congruent and a singular angle marked congruent. However, order does matter here. All right. So for all of these postulates, order matters. Meaning that angle cannot just be any random angle marked. All right. It's got to be in a specific position in order for the SAS postulate to work. So it's saying that if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. Now, all included angle means is that it's between the congruent sides. That's all it means. It's between the congruent sides. All right. So let's look at these pictures. So if I look at the first one, All right, let's call it ABC and DEF. Now, if we look, we already have two sets of congruent sides, that'd be AB and DE, as well as BC and EF. So there's our two congruent sides. Now, I'm looking for the congruent angle to be in between these two sides. In other words, it's going to be the angle that is formed when you connect these two sides. All right, that's another way you can think about it. It's the angle formed when you connect the two congruent sides. So that would be angle ABC and DEF. Are those two angles marked as congruent? Technically, yes, because what's true about these two angles? What's the measure of these two angles? What does the square mean, guys? 90. Is it not true that 90 is going to always be congruent to 90, no matter how we look at it? Right. They're both right triangles, so they automatically have to be congruent. So again, it's the angle formed by the two congruent sides. So wherever those two congruent sides intersect, it's that angle that you're looking at, always. It's not going to be this angle. It's not going to be this angle. We'll talk about why that is in a second. So because we have two sides and the included angle congruent, we can say that triangle ABC is congruent to triangle DEF by side angle side. Now, why we think that's enough information to prove that these triangles are congruent? Well, let's think about it. If we know that these two sides are congruent, great. We know that when they meet, they're going to form the same angle. All right? So that's already like most of the triangle right there, because then what happens is that these two sides are congruent and they form the same angle, meaning that they're separated the same length. Automatically, that means the non-marked side has to be congruent because this distance from here to here, because they form the same angle, has to be the same. All right? And then the other two angles will fall into play because of how this side will connect to these two. All right? So that's why this is enough information. Okay, we're basically making like the bottom of the cone of the triangle, and then the top of the cone will always be the same because of that. All right, look at the second one. So let's call this A, B, C, D. Now, I have a side marked congruent. I have an angle marked congruent on each triangle. So I'm not quite at SAS yet, but what else can I mark to be congruent? That's obviously congruent. DB. All right, because they share that side again, so we got another reflexive property. So now, is that angle between the two congruent sides? So is the marked congruent angle between the two congruent sides? Yes or no? Yeah, it is. In other words, this angle is formed by those two congruent sides. Same thing here, it's formed by them. All right? So, how would I state that these two triangles are congruent? How would I name it? So triangle what? The first one's easy. You can name it any way you want, as long as you use the correct letters. So how do you want to name the first triangle?
ABD.
All right, ABD. Now the second triangle, we got to use the corresponding sides. So triangle ABD is congruent to what triangle? CBD. Good. By SAS. Any questions on these two postulates? Now, look at this next problem. So it asks, why can't we use SAS to show that these two triangles are congruent? So to make it a little easier, let's mark this side. So A, B, C, and D, E, F. So look at the sides carefully. Why can I not say that these two triangles are congruent by SAS, Luke?
Because the angles are in different places.
The angles are in different places. Good. So would SAS work for ABC? So in other words, is this angle between the two congruent sides?
Yeah.
Yes, it is. It's formed by the two congruent sides. What about BEF? No. If you look, the angle that we want marked would be right here. But it's not. This one is right here. So if we went around a circle, this would be side, angle, side. But this would be angle, side, side. Now, think about for a minute what that spells.
Yeah.
All right? There will be no X's in my class. All right? In other words, this is not a congruence postulate, whether it's spelled forwards or backwards, so SSA or ASS. Does not work to show congruency. All right? So it's because of this triangle right here. The angle is not between the two sides. So this is technically SSA, which does not prove congruency. So SSA, just remember what it is backwards, never going to work with congruency, ever. All right. Now, another thing that you got to know is that sometimes we have to mark assumptions. So remember what I said last week. It's like a court case. We can't mark something congruent unless we have enough proof to show that they're congruent. Now, when it comes to these pictures, the only way you can mark things congruent is if it's really, really obvious that they're congruent. In other words, like the first one, it says the reflexive property. We already talked about that. It's where two triangles share a side. So that side has to be congruent to itself. All right, so in other words, if I had these two triangles marked, the reflexive property would be that side that we can mark congruent to itself because they share it. Now, we also have the third angle theorem, which we also talked about last week. So that is when two pairs of corresponding angles are congruent, then the third pair has to also be congruent. All right, and why is that? Because of triangle sum theorem. Because they have to add to 180. So for example, if I have two different triangles, and I marked two sets of corresponding angles congruent. So in other words, let's say that this was 50, this was 100 for both. Then I could mark the third angle congruent. Because if that angle is 100, the other one's 50, no matter how I slice it, that third angle is going to have to be what? How many degrees? 30. No matter how I slice it. That's what the third angle theorem says. If we have two congruent angles already marked, the third one has to also be congruent to its corresponding pair. Because no matter how you slice it, it's going to always be the same number. And then the last one is vertical angles. So just like we did on the board earlier. So we already know that vertical angles are congruent. All right, it's just a known fact. Vertical angles are congruent. So if I have two triangles that look like they form an X, all right, the vertical angles, even if they're not already marked, I can mark congruent because we know that vertical angles are congruent. That's just a known fact. Now, there may be some other angle relationships that we can also mark. For example, alternate interiors, like we talked about with parallel lines and transversals. However, that's only in very special cases, and we'll talk about that later. All right. Now, this is very important. Corresponding does not necessarily mean congruent. Only mark sides and angles we can justify. So, in other words, you cannot eyeball it. It may look like they're congruent triangles, but for all we know, it may be slightly smaller or slightly bigger than the other triangle. All right, unless it's marked, you can't say it's congruent unless you can justify it. That's the only way. All right. So let's look at these two. So the one on the left, first off, when we're looking at the one on the left, is there anything else I can mark congruent that I need to mark congruent? So anything using any of the assumptions up top, can I mark anything else congruent on this picture? I can mark the shared side by the reflexive property. So now that I've marked all I can mark, what is this triangle congruent by? By what postulate? Side, 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 because all three sides are congruent. All right, someone besides Ephraim, is there anything else I can mark on the second picture that we know for a fact is congruent? The two vertical angles. So since I marked that, what are those two triangles congruent by? What postulate? Side, angle, side, or SAS? Now, what additional piece of information do I need to prove that these two triangles below are congruent by SAS? So we want these triangles to be congruent by side, angle, side. So they already gave us two pairs of congruent sides. So I already have two pairs of congruent sides. If I want SAS, what do I also need? We need an angle. Which angle specifically? Which two angles specifically do we have to prove congruent? L and H. All right, so we're going to get in the habit of marking with three letters. So we'll call it MLK. Remember the angle we want. The vertex is always the center. We need to prove that it's congruent to angle GHI. So again, that's just fancy for saying angle L is congruent to angle H. That's what we got to prove congruent. Now we're not going to, but it's just asking what additional piece of information do you need? Now, if we use those same triangles up top, all right, what additional piece of information do we need for it to be congruent by side, side, side? So if we're using the same triangles up top, remember, we only originally marked the two sides. What do I need to show it's congruent by side, side, side? Which side specifically? MK and what? Nope. It's GI. So we need to show that these two sides are congruent. It goes by SSS. All right, any questions? All right. Now, that was the first part of triangle congruence. Now let's look at the other postulates. So go to page 26. So we've talked about SSS, side, 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 and SAS, side, angle, side. There's three more postulates. All right, that'll be ASA, AAS, and HL. All right. So the first one we got is ASA. What do you think ASA stands for? Angle, side, angle. Now, make sure that you pay attention to this one and the next one because they're very, very similar, but it's all about the placement of that one singular side that's congruent. All right? So, ASA states that if two angles and the included side, so remember, included side, it's going to be between the congruent angles of one triangle are congruent, and two angles in the included side of a second triangle are congruent to it. And the two triangles have to be congruent. So, the included side has to be between the two congruent angles. In other words, both angles need to be formed by this side. So in other words, one of the sides that make up both of those angles has to be that congruent side. That's what it means by congruent side. All right, or included side, sorry. So if I look at this one specifically, look where the placement of that congruent side is. Is it not between the two marked congruent angles? Like it's directly between them? Yes. So we have a congruent angle, and then the congruent side. So because of that, we can say that these, yes. So we can say that these two triangles are congruent by ASA, side, angle, side. Sorry, angle, side, angle. Okay, look at this one. Someone who has not talked yet today. Can I mark another side or angle to be congruent? So it's congruent by angle, side, angle. So we got two sets of angles marked congruent. I need a side now. Which side can I mark that we obviously know is congruent? Owen.
HJ.
Right. HJ is congruent to itself. So we can mark it as congruent because they share it. So is this side between the two sets of congruent angles? Yes. All right. We have the two congruent angles here and the two congruent angles here. And that side is directly in between them. So once again, we can say that those two triangles are congruent by ASA. Now, here's why I said it's really important you know that position of that side. Because we have a postulate that's ASA, so angle, side, angle. But then we have a postulate that's angle, angle, side. All right, and they are different. So AAS stands for angle, angle, side. And all it states is if two angles and the non-included side, meaning it's not between the congruent angles. So it's not between those congruent angles. That's what non-included side means. Of one triangle are congruent to two angles in the corresponding non-included side of the second triangle, then the two triangles are congruent. So, if I look at this example, here's my two sets of congruent angles, and here's my congruent side. Now, this would be by angle, angle, side, but here's my question. Is this side directly between those two congruent angles? So in other words, is this side, does it not have another side between it to be between these two angles? So guys, is this side between the two angles? It looks like they're between them. However, what I mean by between is is that if we go from this angle to this angle, we won't hit another side. There'll just be one side. So in other words, if I go from this angle to this angle and I have to bypass this congruent side, how many sides am I actually going through if I rotate around it? To get from yellow to green, if I go through the congruent side? 2. All right. So my question is it truly between those two angles? No, it's not. Because it has that second side in between it. The side that would be between the two angles is this side right here, because it's a direct shot. So what I mean by between is I want the direct path to the angle. We're not turning a corner, nothing. All right. So since that side is not my direct path to the two angles, it's not the included side. So this is the non-included side, which means this is congruent by angle, angle, side. Because these two sides are the non-included side. It's not the direct path to the two congruent angles. If I look at this one, first off, can I mark anything? Is there anything that I need to mark? KM, because reflexive property. So, is KM the included side or the non-included side? So in other words, if I go from, if I look at the two sets of congruent angles, is KM going to be the line that's the direct path between those angles? No. I can't go from the blue to the green directly using KM. I have to go around. So because of that, still angle, angle, side. Does everyone understand the difference between angle, angle, side and angle, side, angle? So again, angle, side, angle, the side will be the direct path between the two congruent angles. Angle, angle, side, the side will be the non-direct path between the two angles. So again, third angles theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third angle of the triangles have to be congruent. We already talked about that. All right, and here's the example. So they said that if C is congruent to K and B is congruent to J, that means that A has to be congruent to L. And again, that's just logic because we know all triangles have to add up to 180. So if 2 out of those 3 angles are congruent, it has to be the same thing for the other one. Now, let's do a couple of examples here. So look at number 1. First off, is there anything I can mark? Anything that I need to mark? So anything I can mark congruent besides what's already marked? The shared side. So since I marked that, what postulate are these two triangles congruent by? So look at the placement of the angles, the placement of the side. What postulate are they congruent by? ASA, angle, side, angle. Okay. Look at number 3. Anything I can mark? We can mark the vertical angles as congruent. And I'm going to use 2 ticks because they already have one marked with 1 tick. So now, what can I say that these two triangles are congruent by? What postulate? Someone who has not talked yet today. What do you think? Angle, angle, side. Good. That side is not the direct path between the two congruent angles. So it's angle, angle, side. Now, look at 4. So with 4, let me ask you this. Do I have enough information to say it's congruent through any postulate? No. Why? So why can't I mark anything? So first off, can I mark anything else as congruent? No, because since they're not connected, I can't mark any sides congruent because there's no reflexive property. Since they're not connected, there's no vertical angles to mark. So we have to take it at face value. So they only mark 2 sets of sides congruent. Is that enough information to show that all 3 sides are congruent? No. Is that enough information to show that these 2 angles are congruent? No. So what we would say for these is that we can't say that they're not congruent. All we can say is that we don't have enough info. We don't have enough info to say that it's congruent or not. Because there's not enough stuff marked and there's no assumptions that we can make that we know for a fact is true. All right. So if I'm looking at the first triangle or first set of triangles, what do I need to show in order to show that those 2 triangles are congruent by ASA? So I already got a side marked and I got an angle marked. So I need another angle to be marked. Which angle do I need to mark? Or which 2 angles do I need to mark? So it's congruent by ASA. Nope, that's the side. I need angles. So 3 letters if you name it. So angle, side, angle.
ABD.
ABD is one of them. Good. So in order for it to be angle, side, angle, meaning that congruent side is the direct path between the 2 congruent angles, I have to say that angle ABD is congruent to angle CBD. Now, this next picture, how could I say it's congruent by AAS? So what do I need to mark for it to be congruent as AAS? Someone besides Ephraim. JKN is one of them. What's the other one? So what's its corresponding? LKM. Good. Now, we could have marked those already because they were vertical, but it's just asking like, oh, what do I need to mark for it to be AAS? All right. And if you've noticed, the side is not the direct path in between the 2 angles, so it is AAS. So we had to show that angle JKN was congruent to angle MKL. Yes. Yes. Go. All right. Now, go down to the bottom of page 28. So, these are the congruence postulates that do not work. All right? So, they do not work. So, if you see this method of marking, it's not, we don't have enough information to say they're congruent. So, the first one is AAA or just AA because of the third angle theorem. So in other words, angle, 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 or just angle, angle. Either way, it's the exact same thing. All right. So in other words, if we had 3 angles marked as congruent on one triangle, and they are the 3 angles of another triangle. So why do you think I made the second triangle bigger? Well, to show they're not equal for one, but think about this logically. When we back in unit 1, what transformation contained the same shape, but they were different sizes. Or no, dilations did. So that's why AAA doesn't work. So angle, angle, angle. Because remember, angles control the shape. So if all three angles are congruent, that means they're the exact same shape. But without at least one congruent side, we cannot show that it's the same size because the sides control the size. So if no sides are marked congruent, then we can assume, we don't have enough information to assume they're congruent because dilations are a thing. All right, so that's why AAA doesn't work because it shows same shape, but there's not enough information for same size. Now, the other one is SSA. I already told you what that is spelled backwards. All right, that's how you remember it. So, SSA. So that means we got an angle and then two sides. Now, why does it not work? Well, it doesn't work because even though these two sides are congruent, remember what I said, this angle between them, if it's not already marked, could be anything. That's why side angle side works. But why SSA wouldn't work is because if this is the angle marked, this side could be this different length than this side and still give you the same angle and still be connected by the same side length. All right, that's why. So what controls the length of this side is this angle. So that's why side angle side works. All right, this angle does not control this side's size. So that's why SSA can't work. Yes, you can go to the restroom. Now, there is a special case of SSA that does work, which is HL. So the only case that SSA works is HL. So the only way SSA works is in right triangles. In other words, HL means hypotenuse leg. Which states that in a right triangle, so it specifically has to be a right triangle. All right. If the hypotenuse of two triangles are congruent and the corresponding legs are congruent, then the triangles are congruent. So, in other words, if I have two right triangles here, so they have that right angle already marked. Remember, the hypotenuse is always the side that's where? How do I know which side's the hypotenuse? It should be where? Well, it's the longest side, but how do I know it's the longest side? It's always going to be where? What angle is it always going to be across from? The 90. It's always going to be across from the 90-degree angle. So the hypotenuse is right here. So if the hypotenuse is marked congruent and a corresponding leg is marked congruent, meaning any other side of the right triangle, so let's just say this one, then the two triangles are congruent. If you look, it is technically SSA because you have an angle that's not directly between the two sides. But since it's a 90-degree angle, all right, that's why it works. Because that 90-degree angle is always going to be congruent between these two triangles. That's the only reason that SSA works, but we call it hypotenuse leg. All right, so we don't call it SSA, we call it hypotenuse leg, or just HL. All right. Any questions on these postulates? All right. So let's just do a couple more practice, just to be quick. So we're going to do a little game here. So I want you guys to tell me what postulate is showing that those two triangles are congruent for each one with a show of fingers. So if you just have a fist up, that means there's not enough info. You show congruence. If you have 1, it's SSS. 2, SAS. 3, ASA. 4, AAS. And 5 is HL. All right. So again, 0 means you don't have enough info to show they're congruent. 1 is SSS, 2 is SAS, 3 ASA, 4 AAS, 5 HL. All right. So look at number 1. Take a minute, look at it. Don't raise your fingers until I tell you to. Is number 1, are the two triangles congruent? And if so, by what postulate? All right, look at the chart. See how many fingers you're going to raise? You're going to raise them in 3, 2, 1. What do you think? If you had one finger up, you're correct. It's definitely side, side, side. Because only the sides are marked. All right. What about number 5? Think about it. Remember, you can also make an assumption if it's something that you can definitely make. So remember your properties: reflexive, third angle, vertical angles. All right. What do you think these two triangles are congruent by? Raise your fingers in 3, 2, 1. We're all over the place. Okay. So first off, this is by side, side, side. Why? There's only one assumption I can make to mark something else congruent. What is it? The side that they share. So I can mark this side as congruent to itself. Now I got 3 congruent sides marked. So remember, you cannot make an assumption unless it's justified. Sharing a side is justified. All right? However, just making an angle congruent, so like these two, that's not justified. All right, let's try number 2. So look at it. Look specifically where the two sides are. All right. Raise your fingers in 3, 2, 1. All right. So I see some discord. So some of you are saying it's hypotenuse leg. Some of you are saying it's side angle side. First off, here's my question. I picked this one because I knew that would happen. All right. Now, they are right triangles, yes. But hypotenuse leg, what definitely has to be marked? In hypotenuse leg, what absolutely has to be marked in a right triangle? It's kind of in the name.
No.
The hypotenuse. Is the hypotenuse marked in this triangle? So in other words, is the side across from the 90-degree angle marked? No, it's not marked. So it can't be hypotenuse leg because the hypotenuse is not marked. But we do have 2 sides with an angle in between marked because we know 90-degree angles are congruent. So this is actually side angle side. What about number 6? So, number 6. Think about it. All right, raise in 3, 2, 1. What do you think? So do we have enough info? Is it a postulate? Good. If you have a fist, you're correct. It is not side, side, side. Why? What's actually marked? Are the sides marked? No. What is marked? The angles. So even though there are 3 things marked, it's not the sides, it's the angles, which we know that angle, angle, angle is not enough info to show congruence. So we would just put not enough info. All right. What about number 7? So think about for a second. Think about any assumptions you can definitely make and mark. All right. Raise in 3, 2, 1. Go. You got 2 fingers raised. You're correct. Side angle side. Why? What can I mark? I can mark the vertical angles. So it's not side, side, side because we can't make the assumption that these 2 sides are congruent. But we can make the assumption that since these 2 angles are vertical to each other, they're congruent. All right. Let's go to the second part, number 1. Same page as the second part. Look at it. What do you guys think? All right, raise in 3, 2, 1. What do you think? Good. It is angle side angle. Good job, guys. All right. What about 2? So first off, think about anything you can mark from an assumption. I'm basically giving you the hint here. And then think about whether it's enough info or if we can use postulate. All right, raise in 3, 2, 1. What do you think? Okay. So I see a lot of difference. If you have 5 fingers up, you're correct. So first off, what can I mark? I can mark the shared side. Now, it's a right triangle. So if you look, the only marked angle is the 90-degree angle. That would be the congruent angle. Is it between the 2 sides? So in other words, is it going to be side angle side? No, because it's not directly between the 2 sides. That would be this angle. So we know it's going to be a side-side angle. However, since it is a right triangle, remember that's the only case of side-side angle that works. So, and the hypotenuse is 100% marked. All right, so it has to be a hypotenuse leg. All right, one more. Let's do 4. So think about what you can definitely mark. If you need to mark anything extra. Okay. Raise in 3, 2, 1. What do you think? Okay, I see some 3s. I see some fists. But I do not see what I'm thinking of. So none of you are correct. So let's talk about it. First off, what can I mark for sure? They share the same side. I can definitely mark that. Now, 2 angles and a side. That means it can be one of 2 things. It can either be ASA or AAS. All right, that's how you can figure out essentially what postulate you're using. Look at what's marked. All right, now, remember what I said about the side. That the position of that side tells you whether it's ASA or AAS. Is that side the direct path between those two marked angles? No. So is it going to be ASA or AAS? AAS. Remember, ASA, that side would be the direct path between the two angles. AAS, it's not the direct path. Any questions on these postulates? You've got to be able to identify them. All right, so here's what you guys are doing for the rest of class. There are two very short delta math. I separated them based off of the postulates. So the first delta math covers SSS and SAS. The second one covers the other three. All right, they're both super duper short. Well, then you got the other one to do. You got another one to do because I just posted one this morning. So there's two different 2.4s. There's 2.4 part 1, 2.4 part 2. So if you did 2.4 part 1, then work on part 2.